Good morning, good afternoon, or good evening, depending on where you are, and welcome to the Nautel webinar on transmitter site safety. We're trying to develop safe working habits and procedures, and today I'm joined by Jeff Welton, our former customer service manager, regional sales manager for the Midwest region, and all-around good guy. Welcome, Jeff.
Well, thanks, Chuck. Good to be here.
Let's go to the next slide. Okay, so the things we're going to talk about today are the challenge that safety makes, things going on in our industry that makes it even so much more difficult, including the fact that if you go to a meeting of broadcast engineers, a lot of them are gray now. A lot of us are gray now, and we're doing more with less, more stations with the same number of people or less people. Why it's a challenge is the risks, the liabilities, good working practices, what we do at Nautel when we're building your transmitter, and what you can do. And then we're going to, as always, we're going to take your questions. And do remember that you can ask questions at any time. You can, in the application for GoToWebinar on the right-hand side of the page, you can see a place to type questions. You can do that at any point during the webinar. We will answer the questions all at once at the end of the webinar. And if for some reason we don't get to your particular question, we will answer offline and send you an email, because we have all your email addresses. Do remember that the completion of a Nautel webinar qualifies for a half of an SBE recertification credit identified under Category 1 of the recertification schedule for SBE certifications. So Jeff, not to be too melodramatic, but this is really what this webinar is all about.
It really is, Chuck. I mean, especially for me, I've done field work for station engineers. Everybody gets called out. You get called out under all kinds of situations, and usually
the pressure is high.
Usually they're not the most cheerful situations.
Yep.
And the end goal of all of it is, how do we get home tonight?
I have to share a story with you, Jeff. Back 40 years ago, I was thinking about that this morning. This happened exactly 40 years ago. I was a brand new newbie chief engineer of a radio station in southwestern Colorado. And the very first day after I got the job, the general manager of the station, a lovely lady, directed me that my first task was to go up to the FM site at 8,500 feet, and she had some cleanup work that I needed to do up there. And when I got there, what I found was a lot of human flesh fused to the concrete floor behind the transmitter. And what had happened, as I learned, because nothing had changed, is the previous chief engineer had defeated the interlocks. The interlocks were still defeated. The door was still open. He had put a green leaf punch through the side of the transmitter, and he was in the process of using a big crescent wrench to pull that green leaf punch through the side of the transmitter so he could add a new AC feed. And somehow his right arm got across the 8,000 volts B plus in that transmitter. And fortunately for him, I say this, his right knee was down on the concrete behind the transmitter, and that's what the right hand got the voltage, went down through his torso to the right leg. Had it been the left leg, potentially he could have died, but he survived, although I think with severe disabilities as years went by. And I can't honestly imagine any better lesson for a young engineer like myself than that lesson that this general manager chose. She could have gone up there and had that cleaned up by anybody, but she chose to send me up there on my first day of work to clean up, to experience the smell, to experience the opened interlocks, to experience the door being open and the 8,000 volts on the PA meter on the front. And she did that for a very specific reason, I now realize. And it stuck with me, and I'm still around. Maybe it gave me pause, as I've been in many, many, many transmitter sites ever since.
It's certainly a fast way to learn respect, that's for sure.
And I think that's really what this is all about, because it happened, not to me, but to a situation, to a guy who had never imagined it could happen to him, and it changed his life. And you've assembled, Jeff, some examples of more unfortunate situations that occur and continue to occur in our industry today.
About 3 years ago when I started working on safety type presentations, I did a quick Google search on the phrase engineer found at transmitter site, and these were the top three that jumped out at me. But there were well over 10,000 different hits.
Wow. Now, some of them would be redundant with the same instance, but yes, I understand.
There was a lot. There were way too many. One is way too many.
Absolutely. Absolutely. And part of the reason for that is that, as I mentioned, we are getting older, and that has two effects. Number one is that there's less of us to go around. There's less of us to answer that phone when somebody needs a transmitter put back on the air. And secondarily, when there are new people that come in, maybe they don't come in with the same range of experience that the years of experience that you, Jeff, or I have, or many of our listeners have today.
Well, and that's what the next couple of slides cover. John Poirier did a wonderful presentation at the NAB broadcast conference about 3 years ago, 2012, and I'm going to flip back and forth. But if you look at the average age of the SBE membership in 2001 and then compare it to 2011, what you see is that the average age went up, and in fact it went up by 4 years over that 10-year period. Meaning that, we're getting older and there aren't as many younger people coming in. And as you say, definitely one of the situations we're seeing is that a lot of the younger people coming in are much more IT oriented and not so much RF.
Well, and our jobs are much more IT oriented, to be fair. There's a lot more stuff that goes on today that is IT oriented than there was 10 years ago.
Absolutely, but you still see the comments, people working on RCA BTA series transmitters, some of the older, any tube transmitter, you got thousands of volts in there. It's all got a big AC power supply feeding it, and in AM transmitters, there's still a whole lot of watts going up the pipe.
And I've worked on a lot of computers, built a lot of PCs and things like that, and I've never gotten shocked because there's just not those voltages inside.
As a rule, no. I mean, 110 volts AC is not going to surprise you so much.
But even those are in the shielded case that a PC power supply is in. The voltages that on the motherboard are not high enough to cause you any major headaches.
No.
Okay, so an IT person may come in desensitized because of his experience of working with quote-unquote electronics, but not getting shocked.
Exactly, and the challenge is twofold. Number one, you have to have respect for, especially if you're walking into something like the WISN 9-tower phaser out of Milwaukee. But in addition to having respect for it, you've got to not be afraid of it, because you can either cripple yourself from doing your job or inadvertently put yourself in a dangerous situation trying to avoid another one.
Yep. That's a perfect example, by the way. I mean, if you go back to that slide there of the phaser, people used to have this. There's not so much common today. Typically, a phaser is a smaller cabinet that's sealed, and sometimes even interlocks on it and things like that, which is a good thing. But this is a walk around inside the phaser type of cabinet, and you inadvertently slip or trip or whatever, and you're forging that line between high voltage and ground.
Yeah, and I mean, it's a situation that even though it's less common, I still run into it. I've walked into transmitter sites as recently as within the last year where there'd be an open 2-tower phaser on the sidewall of the transmitter room and the transmitter 2 feet in front of it. And you really have to exercise some care and caution if there's not a protective shield over the front of that thing.
Mm-hmm.
One of the other things that we see a lot more is that where transmitters are becoming solid state, they have a lot more redundancy, they get less off-air time, and a lot of the repairs can be done on air during the daytime hours.
Hot pluggability, et cetera.
Et cetera, exactly. The challenge to that is that some of the management perception is that just because the thing's still on the air, there hasn't been a problem. And
and there's also a perception that if it's solid state, you're not going to get shocked.
And ultimately, that's not necessarily the case.
No.
I mean, even with our FM gear where the supplies are well protected and the plugs are, there are still places where if you really work at it, you can come across 400 volts DC, and that'll get your attention in a heartbeat.
Well, and it's not just that. It's also that when you talk, even if you're talking about power supplies that are a maximum of 50 volts inside an FM transmitter, when you get all of the RF power amplifiers summed up and hook into that output connector, just the plain old PIE causes high voltages to be there. P equals I times E causes the high voltages to be there, and it doesn't make any difference whether those voltages are generated by solid state devices or tube type devices. There's still more than enough to kill you.
Well, exactly. And if you've ever been at a site when an FM antenna was busy burning a bay off the top of the tower with molten copper dripping down around the base, I mean, there are still a lot of volts there.
Yep.
The other challenge, and it comes back to the less is more comment that you made earlier, is that we don't run into manned transmitter sites very rarely in North America anymore.
Right.
Overseas, we do still see quite a few. But there are very few people whose maintenance and operations budgets have gone up in the past 10 or 15 years. And it's becoming a bigger challenge there, too, because you'll work a full day and then you'll go work all night at the transmitter site.
Right. That's right. Okay.
All right. Now, this comes back to what I said earlier, where with the higher level of redundancy, a lot of times without an interruption to the broadcast, it's interpreted as no failure. So why do you need to go out to the transmitter site to do preventative maintenance? And ultimately, from a safety perspective, preventative maintenance is one of the best things you can do, keeping the weeds trimmed back, keeping the dust cleared out, keeping things so they don't fail and go up in flames.
Well, there's another point to that, too, and that is that because you people have day jobs and they maintain the studios during the daytime, oftentimes transmitter maintenance is done late at night. And by definition, there's two issues with that. One is that oftentimes people can't get anybody else to come with them, so they end up doing the work alone. And that's just wrong. That's just wrong on so many levels. And the second thing is that they end up going to these places and working while they're dead tired. They're barely keeping their eyes open, and that's also wrong. It's, driving a car can kill you, and if you drive drunk or you drive mostly asleep, you're a danger to yourself and other people. A transmitter is just as deadly.
Well, and that just a real quick war story of my own that was more equipment related than personnel related. I mean, early on in the service days, I was installing a 50 kilowatt out west. I flew, by the time you get to the airport here, get through the airport and get to the other end, it's 3 o'clock in the afternoon there. I've been traveling 12 hours and awake for 15.
Yep.
When we go to the transmitter site, we install the transmitter, and in the process of demonstrating various features of it, I did something kind of dumb and plugged a crystal into a live circuit board and discovered that crystals don't come up on any specific frequency, especially not the ones stamped onto the case.
The pets don't like that.
I blew about somewhere between $10,000 and $20,000 worth of amplifiers up that day.
Oops.
On the plus side, the customer got really good at amplifier repair that night.
And you didn't die. So you could have done something dumb, and you could have died.
Dumber.
Yeah.
But yeah, and that's what it comes back to. I'm going to skip past this slide, but it comes back to the concept or the thought that working overtired is not just a risk to you; it's a risk to equipment. It's the risk is just so many levels that it's just hard to justify it.
There's an interesting parallel to what we're talking about, Jeff. In Nova Scotia, where we are at the moment, there's quite a focus by the government authorities on people who work as roofers. Because if you do something wrong as a roofer, you fall off and you die. And that makes the press. And it's interesting that they have now all kinds of regulations about the training of these roofers, how these roofers have to work in pairs, and particularly the personal protective equipment, lines that are tethered on, and all these things that people have to wear. It's the law. And if somebody catches you, one of these government inspectors catches you without having put on that personal protective equipment, if it wasn't provided by the owner of the company you work for, he's in deep doo-doo. If you haven't worn it and he has provided it, you're fired. And it's that kind of very strong decision-making, making this a real thing, that it's interesting to me that it's just as potentially fatal working in a transmitter site, and there's nobody talking about this.
Yep. And I mean, it's one of those historically you went in and you did the job. And I mean, in the U.S., for example, the Code of Federal Regulation specifies if you're not trained to work on it, you should not be working on it. Actually, you will not be working on it, period. And it's hard to qualify because there's not a lot of training for transmitter repair out there. You know, obviously there's legal implications, which we're not going to focus on a whole lot because, I mean, really, we're just worried more about the personal implications of it. But depending on the country, there could be umpteen different investigations, civil lawsuits, and all kinds of just bad lawyer stuff.
That's right.
So, you know, over and above, like I said before, we've got, beside the personal injury thing, which is the biggest part, you've got off-air time, you've got equipment failure, you know, increased Jeff blowing up a transmitter because he was too tired to be working on it.
Sure.
So there's definitely other risks as well. And that's why having proper procedures in place are so critical. And I mean, here at Nautel, we've got safety procedures. We've got 19 different safety procedures covering everything from lifting boxes and moving transmitters to what you can work on alone and what you need to have supervisory capability in the room for.
Well, and we also require people to take training on these things and then test them on regular intervals. They can't do this stuff unless they're trained.
That's right, and not only trained on working on the equipment, but trained in the actual safety procedures related to their job. I mean, and what I've got up on the screen right now is an example. Nobody works on a transmitter higher than 1 kilowatt output power without somebody else in the room. Now, that somebody else doesn't need to know anything about transmitters. All they need to know is how to disconnect power, how to call 911, and how to start CPR.
That's right.
But, and that's what I get to when I'm doing this training out in SBE chapters and at various trade shows, is that having somebody else on the site is paramount. And I mean, they don't necessarily need to be another engineer. It could be
your wife.
Could be your wife, could be a DJ. I mean,
sure.
Just show them where the breaker is, how to kill the power, and
how not to touch somebody that's connected to the power.
That's always
disconnect the power first.
But, you know, very basic things for somebody else on site to help protect you.
I think there's another aspect to this, Jeff, that I want to talk about as well, though, and it's the whole concept of safety absolutes. If you come up with all these safety procedures, but you're allowed to bypass them if, golly, if you really need to get this station back on, we're carrying the Super Bowl and doggone it, it needs to get on, then you really don't have safety procedures in place. And by safety absolutes, I mean things that are so inappropriate to do, so risky to do, that it could cost your life. Then it should cost your job.
There is a slide about this a little further down, but yeah, absolutely. A procedure that's not enforced isn't a procedure, it's just a suggestion.
Right.
And when you get right down to it, that's a scary position to be in.
So on this slide, we don't actually suggest that everybody take these 3 points and implement them within their stations. You need to develop your own. Yes. There are specific concerns. For instance, we know of places that are not safe places to be late at night, either because of wild animals or wild people. And there needs to be a safety policy that includes those eventualities and what happens.
I've got customers that will not walk into some of their sites without a sheriff's deputy as an escort. And I mean, things like that. It's situational. You determine the procedure. I mean, what's on the screen is an excerpt from some of our in-house stuff.
Right.
And like Chuck said, I mean, anybody caught violating a safety procedure in-house is subject to termination, and it's termination without cause.
And that's the only way we can say. That's the only way we can say we're serious about this.
That's right.
It's the only way to make it stick.
That's right. So I mean, within your own situations in the field, you'll have to determine what are the absolute unviolatable rules, if you will.
Right.
You know. Things like defeating the safety interlock on a tube transmitter so you can go in and work on the power supply while it's live. I mean, no brainer to most people, but if you're less educated, you may need to have that in writing.
Let's talk about safety interlocks for a second, because I was talking to a friend of mine who's old school broadcast engineer, and he said, you know, all the good transmitters have defeats for their interlocks because they know there are times you actually have to defeat the interlocks and open the back of the transmitter while the transmitter's on. And I said, not anymore. Not anymore, because technology makes it possible. I mean, the one thing that jumps out is I want to turn the transmitter on and see where the flash is inside when I need to know where the arc is occurring. Nowadays, you can take your cell phone, turn the transmitter off, open the back door, put your cell phone inside, put it on record, close the door, turn the thing on, see where the flash, or turn the transmitter back off, recapture the phone, and see where the flash was.
Oh, exactly.
There's technology that makes this possible.
iPhones with infrared camera attachments. There are so many things that you can do that don't involve having your face in the back of a transmitter while it's throwing sparks.
So let's resolve that there are no excuses to bypassing an interlock in a transmitter, period. Let's make that a safety absolute.
In 25 years, I haven't encountered one.
Yeah.
Now, I mean, I haven't encountered everything, but I sure haven't seen anywhere I couldn't work around not having to have an interlock bypass.
Yep.
Now, one of the other things, and this comes back to, and it's funny, as I say, I've been presenting this for about 3 years. I did have a guy come to me just at NAB and tell me that his manager won't let him go to the site alone anymore after she sat in on one of my presentations. So it kind of made me feel like we're at least accomplishing something.
That's great.
And he couldn't decide whether he wanted to compliment me or slap me upside the head. But one of the other things is having the proper protective apparel just as an engineer. And I mean, ESR rated footwear, electric shock resistant footwear, is one of the cheapest, easiest, most convenient things you can do for if you do happen to get across something. And they're rated to handle 18 kilovolts and only pass a milliamp of current. Well, that can be the difference between walking away from a job site and
Sure.
walking away with scars or worse.
That's right.
And I mean, another quick war story, I was on an oil rig in the Persian Gulf because Nautel Field Service guys get to go to all the fun places. Yeah. And I was working on the navigational beacon, and I was, of course, oil rigs, they put them in salt water, which means they have to be repainted almost hourly because salt water is kind of corrosive. So there's always scaffolding bolted to the rig deck here and there, just regular, ordinary aluminum or steel scaffolding. And right outside the transmitter, the pad the transmitter antenna was mounted on was one of these scaffolds, and I'm leaning on it while I talk to one of the local guys. And he comes over and he leans on it and jumps away with a wisp of smoke and a smell of scorched skin and shows me a second-degree burn on his arm. I was wearing ESR shoes and didn't even notice that the scaffold was hot.
Wow.
So, I mean, it can make a difference. And when you get right down to it, there's no excuse not to have something that you can buy for $60 at Walmart.
Well, they're not fashionable.
But
they're okay. And it's better to be alive than fashionable.
You know, I mean, you're not going to be pretty, and the other advantage to them, they have composite plates, so you've got some puncture resistance. They've got steel toes.
That's a big deal.
It is.
We drop things that are heavy and have sharp metal edges and things, and it would be tough to lose your left foot.
Power module for one of our older 50 kilowatts weighs almost 90 pounds.
Yep.
And dropping that on your toes is going to get your attention.
Leave a mark.
One other thing that I don't see a lot out there is work gloves. And I mean, you can buy the mechanics work gloves. They're fairly form-fitting, so you've still got some tensile feel to your fingers. And they're not there to protect against shock. You can buy rubberized ones, but I wouldn't trust them for shock protection. However, if you come across something sharp and jerk back from it,
yep,
they will keep the back of your hand from getting torn up on whatever you run it into.
And you've had personal experience with that.
More than once. I've got the scars to prove it. That's why I wear the gloves now.
Good thinking.
All right. Now, getting back to safety, Chuck, and this is something I'll let you talk about this because you're familiar with the procedure, and you can point out what's wrong with this picture as well, even though I've got it in the tagline.
Yeah, so the whole concept is lockout, tagout, and as I was chief engineer of a bunch of stations for many, many years, I never ran into this in a station. I really didn't. Honestly, in the United States, I never ran into somebody that was really doing this, and so it was a real eye-opener when I got here to Nautel and saw the safety lockout, tagout concept. The concept of you go into the transmitter, but you have to turn off the breakers first or some big switch that allows you to lock the switch in the off position and then take the key and put it in your pocket. And then only then, and then and only then, can you get in the back of the transmitter after discharging capacitors and checking things with O-shoot sticks. But the key is that nobody can go and turn that transmitter on while you're stuck in the back. And it happens. That can happen.
Exactly. And I mean, years ago, before lockout tagout was popular, if I was doing an install, I always had a little wire jumper for the transmitter interlock, and I kept that in my pocket so nobody could turn the transmitter on. But that didn't prevent them from applying the AC. Incidentally, you'll be pleased to know that although you mentioned that you've never seen this in the U.S. before you came here, that picture was taken at a transmitter site about an hour north of where you grew up.
Is that right?
In Illinois, yeah.
Awesome. Awesome.
Now, the problem with that picture is the keys are still in the lock.
Sure.
But definitely lockout tagout is a huge safety factor that adds just merely seconds. Those little lockout brackets that you're looking at there are available at Home Depot in the U.S. and Canada, and I'm sure just about any hardware store elsewhere in the world. They're relatively inexpensive, like $1 a piece. And I mean, they're easy to get.
Now, on some of our high-power AM transmitters, we have a version of that, but on steroids, where you've got all kinds of different locks that all interlock on this one locking assembly. You can't turn the transmitter on until you have all the keys in there in the locked mode.
Yeah, effectively the way it works is that the primary disconnect for the transmitter has a key in it. And
Yep.
until the disconnect is in the off position, you can't close the locking bar to remove that key. That key goes into the transmitter and will allow access to a second key, which can't be removed until the antenna ground switch in the transmitter is closed to ground the antenna connection, at which point you can get the second key, which lets you open up the lockbox that accesses all the cabinet keys.
So this is another important point, and I don't want to bypass it and just mention it very briefly. I want to make a point of it. Even if you have the AC mains disconnected from your transmitter, and even if all the capacitors are discharged with the big stick, if you are working on a transmitter and there is lightning in the area, or there's just the normal static that accumulates on an antenna, you are in jeopardy of getting blown across the room if you get across that antenna.
One more war story. Working a site in Paraguay, putting in a 100 kilowatt transmitter. We had the transmitter shut down. We had the output of the transmitter grounded. We were out looking at something at the base of the tower. The chief engineer grabbed the base of the tower. There was no lightning in the area. It was a sunny, clear day, but there was a 200 kilowatt station a half a mile away.
Oh, yeah.
A quarter wave antenna will receive as well as it will transmit.
Sure.
And he got a really serious RF burn.
Those hurt. They hurt more than DC.
They hurt for a long time.
Yep.
So the point being, and I mean, I've got a lockout title here. Again, this is one of our in-house procedures, but once you write these procedures, they have to be enforced. You have to document the steps to do the lockout, whether it's power off, discharge stuff, lock the breaker, and tag it. Over and above that, you should have a list of the people who are actually qualified to restore operation.
Mm-hmm.
Like, typically, you're not going to want the IT guy bringing up power to a 30-year-old CCA or an old tube rig.
Yeah.
And I don't mean to drop brand names, but
Nope.
they randomly pop in mind. So that's definitely the sort of thing you look at when you're creating these sort of procedures. And coming back to antenna grounding, you should always, if you're working on an AM tower, that tower should be grounded at the base.
Mm-hmm.
If you're on the ATU, if you're working in the transmitter final, I mean, it's nice to have the transmitter down and locked out,
Mm-hmm.
but if you don't have an antenna feed ground, you've only done half the job, and you're still looking at potentially live circuits. And I mean, I've had customers, even with ground sticks, that have gone through after they shut everything down. They went through with the ground stick, grounded everything, and had a broken wire in a lug where they came across and found 5,000 volts,
Yeah.
which will lead me to a couple of slides. But the other thing about a ground stick, if you don't have one, and a lot of modern transmitters where they don't have openly accessible voltage and where they run at lower levels don't have built-in ground sticks, you can build one in a heartbeat for about $20.
Yeah.
You know, just a broomstick, some duct tape, and a set of booster cables.
Well, anything with duct tape is cool. But the one comment that I would make on that is be very, very careful about what you connect to make it ground. In
Yes.
a real factory installed stick, they find the right ground, and
Yes.
it's serious. It would be really easy to clamp that black connector on a part of the chassis that's anodized or painted or something like that and doesn't make good contact, and you think you've got grounding done when you haven't.
Very much, yeah. You want to be sure you're connected to a ground strap, going to a known connected ground rod, and preferably a brazed one that's not going to oxidize and make a bad connection on you.
Yep.
And coming back to my friend that came across the 5,000 volts, once you've gone through with your ground stick and discharged everything, grab either this is an AC alert, or you can grab just a safety voltmeter. The safety voltmeters are cool because they allow you to clamp on one side, like the ground, and just use the meter with the probe clipped into it, so you've got some separation.
Mm-hmm.
Okay.
So they're very high impedance inputs, so therefore there's no actual connection to the high voltage.
Right. And I mean, the theory is that, and we use them exclusively in the test room and engineering labs. And I showed an example here from Fluke along with the model number for both this and the proximity alert meter.
Yep.
Now, the proximity alert, the volt alert, will only work on AC. It will work to a lesser extent on RF, but I'd want to test it on a known hot circuit before I verified that it did function for that. I sure wouldn't trust it unless I'd actually verify.
Do notice as well here that the maximum sensitivity range is 1,000 volts.
Yeah.
There may be tube-type transmitters where that's exceeded, or even the RF stages of transmitters where that's exceeded.
Oh yeah.
Okay.
So, I mean, definitely. Now, the other thing to think about with this, and I've got it in brackets at the top, is that how many times have you opened a breaker and discovered one phase didn't open, even though the actuator moved, but it was still welded closed.
Yeah.
All right, and one other thing we wanted to touch on in this is arc flash, and I'll pass it over to you for a second on this one.
Well, I think the important thing to understand is that voltage really doesn't kill people. Current kills people, and it can kill people in multiple different ways. It's the current passing through the body that does the damage, and one could argue that you don't get that without the voltage, but nevertheless, that's what the bottom line is. But there's another way, too. You can have a high current, very low voltage arc or explosion, really, that can create such an amount of fireball that it causes you significant damage, and that is a big deal. So arc flash is actually a whole new subset of safety protection with separate training courses associated with it, and it doesn't make any difference whether your transmitter is solid state or tube type. Arc flash just simply means high current. And that's what you can have problems in your breaker boxes, as shown here, but you can have problems in your transmitter. You've got hundreds of amperes running around a high-power solid-state transmitter.
Yep, and it ultimately what you've got to look at is the kVA consumption. I mean, if you're running a 50 kilowatt AM off 240 volts, any high-power AM of 100 kilowatts or higher, or even FM on 240, and even you could go as low as a 30 kilowatt FM on 240 single phase, where you've got, in the ballpark of close to a 400 amp service.
But suppose you drop your crescent wrench across the 50 volt bus in an NX or NV40. There's hundreds and hundreds of amperes there.
Our old 50 kilowatt AM was 72 volts at 2,000 amps of current capability.
Incredible. And the plasma ball that is created is hazardous to your health.
And your vision and your
and your facial hair and everything else. I understand.
And there are a lot of guidelines related to that. There is specific protective apparel for working with arc flash risk. And as I said, ultimately you're not supposed to de-energize or energize a breaker connected to that level of power consumption without having this apparel in place.
Yep.
So it is something that a lot of people have a potential liability for, not to mention, like you said, it'll ruin your whole day.
Oh, yeah.
And every other day that isn't going to follow. So it's really important to determine if that applies to any of your situations and to have that equipment on site. And again, let's see. It's one of those things where it could be something as simple as just opening a regular old fuse disconnect and you don't even think about it. I mean, it's something you do 100 times.
If there's a lot of current going through it, it could actually draw an arc across there and you can create plasma real quick.
Yep. And I mean, if you've got, as an example, a shorted power supply transformer, shorted plate transformer, and you close the breaker, you've got that instantaneous current flow right now.
Yep.
Okay, one other thing that comes back, it's safety and it's maintenance all at the same time, because if you do some of the maintenance, you reduce some of the safety hazards. And like checking power supply wiring, I don't know how many times I've seen a 20-year-old transmitter where we go to move something and half the insulation falls off the wires.
Yeah.
Well, all of a sudden that just became a really dangerous box.
Sure it did.
So you should do a fairly regular inspection. The other thing I beat the drum on, you can buy an infrared, one of those laser-guided infrared thermometers from Fluke for $80.
Yeah.
And you should check every circuit breaker in your facility. I mean, the bulk of the transmitter site fires I run into start in a breaker panel.
Yep.
And what happens, of course, copper wires are malleable, and as you compress them in the breaker terminal, they eventually will form to fit that. And if you don't have all the air squeezed out, then they'll become loose.
And it wouldn't hurt to also aim it at the places where the AC feed comes into your transmitter and is connected up to the lugs in the transmitter. Same exact issue.
Any place where you've got a compression connection with either a lug or a bolt down type connection, even a crimp lug. I mean, unless you had the specific crimp tool at the time, there'll be some error in there.
Sounds like we've got the basics of a safety policy forming here.
It does sound like it. And I mean, this is something that, again, you can just go in and do a benchmark, and you can have a checklist, and you could create your own little running log, so you can see if there's a trend where 6 months later this one is running 10 degrees higher than it was 5 years ago or whatever.
Yep.
Okay, one of the other things, and this comes back to your interlocks, if the transmitter has a cover panel, leave it there, especially during, now obviously sometimes you've got to remove them to do maintenance with everything de-energized and shut down properly.
Or sometimes they're installed just for shipping purposes.
That happens too, and somebody who looks a lot like me has left those ones on before. They do tend to put labels on them that say remove this before operating. And,
and don't starve us for air.
Definitely, if they tell you to remove it, remove it.
Sure.
But by all means, and especially if you work on an AM, if you're running an AM with the phaser door open, for example, you've detuned the phaser because the circulating currents in the phaser cabinet are actually part of the circuit.
Yep.
So you can't, for example, tune a phaser and do your fine tuning with the door open.
Yep.
So you've got to kind of take your measurement, close the door, take your measurements,
right,
open the door, tweak something, and it is a longer drawn out
process. But the biggest
process.
problem is, and you may not think of it because you're aware of the danger, but if you inadvertently have somebody who's non-technical who comes to visit you at the site and leans their hand in there, it could be a problem.
Yep, exactly. So definitely protective covers should be in place at all times.
Yep.
All right, so just a very brief recap on it. I mean, obviously, when you're working on something, you lock out the breakers. That's a no-brainer, especially if there's anybody else on site. But if you get into the habit, you do it while you're alone on site, and that way you don't even have to think about it. The other advantage is that the lockout will sort of serve to remind you of things as you go to put the key in the lock to remove it from the lockout. You say, oh, did I close the interlock? Or
right.
Little things as the remote switch back on. I mean, it just sort of can actually help you by slowing you down sometimes when you're tending to run at 140 miles an hour trying to get things back on the air.
Right.
Interlocks, definitely not something that you bypass.
No.
You know, they're not an inconvenience.
It's not optional anymore.
Yeah, we don't put those in there just to be a pain in the rear.
Yeah.
You know, I mean, I could count, I wouldn't be able to count on both hands, I don't think, the number of transmitters we replaced because airflow interlocks had been bypassed and the blower failed, as an example.
Right.
You know, measure anything before you touch it, especially if there's any amount of voltage on it or potentially any amount of voltage on it. We've, even here with all our safety policies, we've had accidents where people have gone across something they were convinced was turned off and locked out to discover that, no, it wasn't.
Yep.
So, you know, what was it they say? Trust, then verify?
Absolutely.
Yeah. And de-energize everything. Okay, and another note about interlocks, you know, but absolutely there are a bunch of things that need to be considered, and most of them are fixed and finite for any specific site. There's only a limited number of places you've got high voltage, and once you've enumerated those, you can develop procedures to work safely around them.
Right.
Okay, I'll let you do the wrap-up on
I
this.
think there's always a potential for danger. AC mains can be up to 600 volts, but even 110 volts. 110 volts kills more people in North America than anything else. Not so much because the voltage itself kills them, but the reaction of jumping back. You hit the back of your head, you fall down, whatever. You stab yourself because you moved into something. It's more fatal because there's so much of it out there. So don't minimize the potential for danger with standard AC line voltages. RF connections, even in AM plants, can carry thousands of volts, carry the grounding stick. Always assume that it is hot. A 300-foot insulated tower can pick up hundreds of volts of static on a windy day when disconnected from the transmitter. It can also pick up hundreds of volts of RF from another station. Messenger cables on long horizontal coax runs can be great antennas. Be careful of transmitters that have bypassed interlocks or modified protective circuitry. As electrical circuits, especially with high current DC supplies, have lots of storage capacity to counteract main sags. These can be hot for a long while after the mains power is removed. One comment that I want to generically make, I think that in North America, in the last 10, 20 years, has gone through a change in the perceived value of life. I think that many of us learned our trade at a time when the responsibility for safety was with the engineer himself, and you were assumed to know what you did and what you didn't do. And a lot of us learned, well, you put one hand in your back pocket and that's enough. Well, it isn't enough. And it was a different time and place. Today, the value of life, and potentially, in a jaundiced view, potentially that's influenced a little bit by the potential for litigation today as opposed to 20 years ago, but the potential for safety becoming a massive issue and a huge, the loss of life becoming a closure of a business kind of event. Is much different today. Less so, I guess, in some of the developing world, but I think it's still proceeding there as well. Eventually, it's coming.
Well, and the other thing that comes in as, like you said, I mean, a lot of times you grew up in it 20, 30 years ago. What you can't assume is that somebody moving into it now has the same level of training and experience that you did 20 or 30 years ago.
Yeah.
And so a lot of these procedures have to be put in place to sort of protect the people coming along who may be used to working with 5 volts DC and nothing much more.
So there's 2 real targets for this, or 3 real targets for this conversation. One is the engineers who have been around the block, who understand what's going on, because we need to up our game. We need to be more careful of safety because safety is a bigger deal today. And the ramifications for unsafe are more important. Number 2 are the newbies coming into our industry, perhaps from the IT field. They need to understand and respect the voltages and currents involved and understand RF and learn these things to protect themselves. But number 3 is the management of our stations. They need to understand that not only are they trying to protect good old Joe, but they're also trying to protect their own cash flow going forward, because they are both, from a business side, liable, but also personally liable in the event that proper OSHA or whatever happens to be the safety body in your country, if those procedures are not followed and it is demonstrated and it causes a death, you can be both from a corporate standpoint as well as a personal standpoint liable.
Exactly, and I mean that's ultimately the goal, as we said at the beginning, is for everybody to walk home at the end of the day.
That's right. Okay, next.
Okay, so we covered all this. Next is questions.
Okay, so we have 4 questions at the moment, and I want to thank the people for bringing the questions. The first one is a very good point. Laverne brings up the point that it's important to mention that capacitors, if they don't have bleeder resistors on them, can store high voltages for a very long time. And that's the purpose of your grounding stick, but it's important to underline that it's capacitors that oftentimes store the charge.
And over and above that, and thanks for bringing that up, Laverne, over and above that, one of the other things I've seen electrolytics, like big ones, 10 millifarad, sitting on a shelf for 5 years.
Oh, and they collect it.
They develop their own charge. And I mean, put a screwdriver across and blow the blade off the screwdriver.
Yep.
So absolutely, if capacitors are taken out for storage, they should have a shorting jumper across them. And if they don't, you want to approach it like it's energized.
Mike asks, Jeff, are the ESR boots also available in the U.S.?
That picture I showed you was taken
from walmartc.ca.
The one, the boots was Walmart.com.
Okay.
I did that for a presentation in Mississippi. So not only is it available in the U.S., but the pricing that was shown was U.S. pricing.
So it's a little cheaper than in Canada.
Yeah.
Grant asks us, I would like to get a copy of this presentation for my coworkers. Is that possible? Absolutely. This webinar we expect to put online, and you can share it with people 24/7, 365. Just look on our webpage, probably by tomorrow. I hope that tomorrow. If we can't get it by then, it'll be Monday. And we'll put it up there, and you can show it to people at any time. Bring it to an SBE meeting. And there's another, and that question, thank you very much, Grant, makes me really happy to hear that question. Thank you. And Chris asks, do you have a draft of a lockout tagout policy for your facility that we could use to model ours after? Actually, I think that's a really good idea. It might be interesting to share some of our safety procedures with people, and we will consider that. Contact your regional sales manager from Nautel and ask him, and we will get that from our safety committee. By the way, do you have a safety committee?
That's the other thing, and we certainly do here. And I mean, for Chris, it's easy enough to print out. Once we print it, it becomes an uncontrolled copy because we have our ISO procedures require us to maintain live copies online. But absolutely, we can do that.
Next slide. And this is where we say thank you. And we also tell you where you can get more information. The Nautel Waves newsletter, our webinars, our YouTube channel where this webinar will actually reside, but it'll also have a link to it from our webinars webpage, and the Nautel store, the chat format, all the ways you can contact Nautel, including communicating with your regional sales representative on this next slide. And remember that you can apply for a half an SBE recertification credit identified under Category 1 of the recertification schedule for SBE certifications. We're very proud to be a part of the SBE certification program and being a part of SBE. So thank you very much for joining us today. We hope this was helpful. We hope you'll be around to shake hands at the next NAB. And thank you. For Jeff Welton, I'm Chuck Kelly saying take care. Bye-bye.